In this video, I'm going to be running through a script that I wrote in Python for a reverse shell. So the script's going to demonstrate some advanced persistence techniques, and when executed on a victim's machine in a Unix-based system, it's going to establish a connection back to the attacker system, which will provide us command execution capabilities, and it also implements some stealth and persistence mechanisms. So in this video, I'm just going to do a quick code walkthrough, and then we'll demonstrate the script. So some key features are continuous connection attempts. It does some process daemonization. We have persistence via cron tab. We have a limited command set for security purposes. It also does some silent error handling and some clean termination. So just to set up real quick, we have our configuration server IP. This is going to be the attacker IP address. It's the connection address that the victim is going to connect back to. On this port 4444, it's a random port. We're going to set up a netcat on this, a netcat listener on this port. You can use another random port if you want. Obviously, you would have to configure this to be your IP address as the attacker. A better design, more sophisticated design, is to make this dynamic such that it doesn't have to be hard-coded in there, but just for demonstration purposes, I hard-coded my IP. This is, probably shouldn't make this public, doesn't matter, it's an added IP address. So first and foremost, we have our connect to server function. So this creates a TCP socket connection to the attacker. It implements continuous reconnection attempts on a loop. It has a 5-second delay between attempts that'll help prevent resource exhaustion. And then it returns an active socket connection when successful, which we're going to pass in here to other functions. Next, we have send data and receive data. These are for data communication, obviously. So the send data encodes and sends data within the command prompt, and then our receive data receives and decodes the incoming commands. We have a buffer size of 1024, which handles typical command responses. For directory navigation, we have two different functions related to giving commands to the shell. For directory navigation, we have cd as a standalone command or a standalone function. It handles directory changes and also has error reporting. It'll default to the home directory when you don't specify a path, and then it'll return the current working directory after the change. Then we have our command execution with execute command. This is one of our most important functions. It splits your command into arguments. Obviously, your first argument is sub-0 here. It will do special handling for cd and kick it back up to the change directory function if you do specify cd as your command. It validates all commands against the allowed commands, which we defined at the top of our script. That's just a good security mechanism. It captures and returns both standard out and standard error, as you can see here. And it does silent error handling to maintain stealth here. The terminate completely function I'm going to circle back to later. Next, we have process daemonization. Process daemonization just lets us run this process independent of the terminal. It's a good thing to add to any type of malware. It implements a double fork technique for true daemonization. If you're not familiar with daemonization, it can be a little complicated, but basically it's going to create a new session with os.set SID here, and it is going to redirect standard in and standard out to dev null, and like I said, it ensures that the process can run independently of the terminal. This is an important part, add cron persistence. This is our persistence mechanism. It adds a script to cron tab for persistence across reboots. So it also checks for existing entries, and what that'll do is it prevents duplicates. So if we didn't have this here, then every time that the user rebooted their system, they'd get a new cron tab entry, which we don't want to turn into like a Russian nesting doll of cron jobs. So it also does silent error handling, and then it uses the absolute path for reliability. And termination handling, going back up here, this removes persistence from the cron tab, and it also kills the process, and it cleanly closes the socket connection. So you don't really want to evoke this. If you're lucky enough to get a shell on a system, you kind of want backdoor access, but if you ever wanted to say clean up and you wanted to exit the shell completely, you're not getting it back unless they re-download it or run the script on their machine. So all you got to do is get them run the machine once, and it's going to stay active indefinitely until you press terminate completely. On their own machine, they would have to kill the process, and they'd have to also identify the cron job and remove it from the cron tab. So killing the process alone for them will not get them out. What they'd have to do is kill the cron job, otherwise it's going to relaunch every time that they reboot their system. So back to the main execution. What we're going to do is have the attacker start a listener on Netcat. The script's going to run on the victim machine. The connection is going to establish automatically, and then the attacker can execute allowed commands, and then if you give terminate, it's going to do clean removal of the script. So now we're going to quickly run through it. I'm going to run on a Kali virtual machine. Obviously, Kali, most people know, is usually used to serve as an attacker machine. Here, we're just going to make it the victim machine because it's simpler from a setup perspective, and we're going to have my host. This is my host terminal. Obviously, we're going to have my host be the attacker. So first thing I'm going to do is set up a listener on port 4444. So now we're listening, and then once we run the script on the victim machine, it should connect right back to us. And there it is. Happened instantaneously. So I'm just going to show on the victim who am I? Kali, working directory, home Kali desktop. Let's run the command on our attacker machine. You can see that it matches. And we have the shell. Great. So real quick, let me just show the process running on the machine, or on the victim machine. Expand it. So this is the process we see here for the script currently running, and I want to show you the cron tab as well. So the cron tab, as you can see, is established here. So when we reboot, this will terminate, this will stay, and once we are booted back in, this will launch this yet again. So what we can do here is I can just terminate the shell session as a attacker, but basically this is going to be looping and trying to do reconnection attempts. So as soon as we launch this listener again, within a few seconds, we're going to get the shell right back. So that's the whole point of having the persistence. Cool. Connection is established. All right, let's just kind of move around. Home Kali. What do we have here? Oh, secrets. So it looks like we have a directory called secrets, and now we have, oh look, a config file. Oh, with an API key and admin credentials. Yep, shouldn't have that exposed. So anyway, we're just doing that to demonstrate how somebody could steal some data off of your desktop if they establish a shell, obviously. So I'm going to set up the listener again, and I want to just show how this shell is going to terminate when I reboot. So let's do a quick reboot. What should happen is, as you can see, we have this connection here. When we reboot, it should kick us out and terminate the connection altogether, and then it should come back. So let's do that. So as you can see, it kicked us out, but I want to run the listener again just so we can see how quickly it'll relaunch our connection. Look, we didn't even authenticate the machine, and it already relaunched our connection. Cool. So let's check out our processes again. We're back. So we can manually kill the process. One second. Sorry. You can manually kill the process with 940 with KillTech 9942. And as you can see, the process is killed. So that's similar like what happened when we rebooted. So now the process is gone. It kicked us out of our terminal access to the machine. But let's run the processes again. As you can see, this process is gone, but we still have the cron tab going. So if we rebooted it again, same thing would happen all over again. The one thing that will change this is if we run the terminate command. So I'm going to reboot it one last time to demonstrate the terminate command. Generally speaking, you don't want to run this command. This is kind of like having an astronaut connected to a space station and then cutting the cord and then drifting off to space. You have no way back onto this box if you terminate this connection, but I want to just show how this is going to work and how it overrides the cron tab such that it's no longer there. So we just showed you how the process came back up on reboot. Let's check it again. We're back again. Let's check the cron tab. And it's still there. So when we run terminate, it's going to kill this and it's going to overwrite this. So it's basically removing the malware from somebody else's machine. So let's just do that. See, it kicked us out of the session. Process is gone. More importantly, cron tab is now empty. So that's it. This is a demonstration of a reverse shell. Obviously use this with caution. Should only be used in pen testing environments. Don't use it maliciously. But it's a good script to demonstrate basic mechanisms as it relates to creating a shell back to a attacker machine. So I hope this was helpful. This is available on my GitHub, which is at I am Chris Quinn. Feel free to use it as you wish. Thanks.